Imagine building a system that processes thousands of events per second, detects patterns in real time, and stores results for instant analysis. That's exactly what we are building today. We are combining Kafka, the streaming backbone of modern data platforms, with Databricks, the cloud-native analytics powerhouse. No theory, just a hands-on project you can deploy yourself. Streaming isn't for analytics. Here's how I made it anyway. But how do you get that data into a system fast enough to matter? Real-world sensors can generate millions of readings per minute. How do you handle that scale without everything collapsing? Let's build the ingestion layer, the critical gateway that must be both lightning fast and bulletproof. This is what separates a toy demo from a production-ready pipeline. But your ingestion layer is a ticking clock. If it cannot keep up, data piles up at the door and your 10-second promise is dead. A slow queue or a single point of failure here means your entire real-time analytics pipeline fails. You need a gateway that scales horizontally instantly, without a single dropped message. Let's architect exactly that. Picture it not as a queue, but as a high-speed, multi-lane expressway. Every sensor reading is a car that must never stop. You need an ingestion system that behaves like this, infinitely scalable lanes appearing on demand to prevent a traffic jam at the source. That's Apache Kafka. It's your immutable, fault-tolerant data highway into the pipeline. But your raw, high-velocity data is useless here. It's just a torrent of numbers. You must transform this chaos. You need to filter out the noise, decode the signals, and prepare every single event for immediate analysis. This is the critical, stateful processing layer, the intelligent traffic control that makes your raw data stream suddenly meaningful and ready for action. Throw out your data warehouse. Real-time analytics is this simple. Now, we define the rules of the game. Your topics are your contract. They determine data flow, retention, and who consumes what. Get this wrong, and your entire stream collapses. Let's create raw sensor readings for ingestion and high-temperature alerts for critical events. This separation is non-negotiable for a clean, scalable architecture. This is where we make our data flow. I'll show you a script that pumps out realistic, structured events, simulating an entire fleet of IoT devices. We will generate everything from temperature to vibration, creating a rich, high-volume stream that your Kafka cluster will ingest. It is the foundation of our live analytics. Let's code it. But here's a critical pitfall. Without a schema, one malformed event can break your entire downstream pipeline. I will show you how to define a strict Avro schema and enforce it at the producer level. This guarantees only valid, structured data ever enters your stream, preventing countless hours of debugging corrupted data later. Let's lock it down. Now, let's verify our data is flowing correctly. In a new terminal, open a console consumer and point it to our topic. Watch as messages appear in real time. Seeing this confirms our producer is healthy, our connection is solid, and our first data pipeline stage is a complete success. It's alive. You think live data pipelines are complex. I built one in an hour. Forget generic clusters. Configure this. Enable Photon for raw speed, set auto-scaling to manage bursts, and use Delta Cache. We are not just running jobs, we are engineering for relentless, low-latency ingestion. Your cluster is the engine. This setup ensures it purrs under streaming load. Watch performance transform. Now, the critical bridge connecting Kafka to Databricks with a secure, high-throughput pipeline. We will install the specialized Spark connector and implement a hardened configuration. This is your data's lifeline. Miss a setting here, and you have built a garden hose when you need a fire hose. Let's lock this down for bulletproof reliability. But how do you ensure your processing engine does not miss a single event during a restart? You do not trust memory. You need durable, cloud-backed storage to persistently track your progress. This is where you will mount your S3 or Azure Data Lake storage. It is your system's memory, your critical safety net for both checkpointing your position in the stream and reliably saving processed results. Hold on. This next step is non-negotiable and often a critical failure point. Hard-coding your Kafka credentials within your notebook code is a massive security flaw, creating a direct path to your data streams. Instead, you will securely store these secrets within Databricks, locking them away from prying eyes and your own source code. Forget everything you think you know about real-time data pipelines. Now you are reading the live stream. Schema inference handles messy JSON automatically. While this watermark is critical, it is your time-bound memory, telling Spark exactly how long to wait for late-arriving data. This single configuration determines what's included in each windowed aggregation, ensuring your real-time insights are both current and correct. But this raw data stream is just a fire hose. Your job is to transform it into intelligent insight. That's where windowed aggregations come in. Instead of a single data point, you are building a rolling average, a smooth, meaningful trend that reveals true performance for every single device in your fleet. Live as it happens. Here's the crucial shift. You are not just detecting anomalies, you are defining them. That business logic is your new law. A standard deviation isn't a math term, it is your automated threshold for action. The stream stops being random data and starts classifying itself, normal operation versus critical alert. You have just taught the system to think. This is the moment where transient streams become your permanent, queryable truth. Forget complex ETL jobs. With one line of code, you land everything into Delta Lake. The system now creates and evolves its own data warehouse as it writes. This is your operational heartbeat, recorded perfectly and ready for analysis. Master streaming but skip the complexity. Two tools replace dozens. Here's proof. Now, we bring those alerts to life. Transform raw detection into a focused, live signal. This is the moment your pipeline becomes a true guardian, continuously filtering, isolating, and surfacing only critical events. Visualize that immediate insight on a live dashboard. You are not just processing data, you are now actively watching it. This focused signal is your final, actionable output. You will instantly visualize critical anomalies on a live dashboard, transforming static processing into dynamic observation. The stream is now a live, watchful system, and this immediate visual intelligence is your ultimate edge. You are commanding the data flow in real time. Watch your dashboard flicker to life as it paints with living data. That anomaly spiking on the graph. Your alert triggered that. This isn't just a chart, it is the system's heartbeat. See the problem the moment it is born. You've built a real-time nervous system, and now you are watching it think. Your system is now sentient. It feels a disturbance and sends a pulse across the wire, a webhook. That digital flare becomes an email, landing in your inbox like an urgent whisper. You are not just monitoring data, you have given your creation a voice. It speaks directly to you, cutting through the noise to signal what matters most. Why do so many stream setups fail? You likely have the wrong foundation. And this is your last, vital line of defense. Without exactly one's semantics, a simple failure, a network blip or a crashed pod can cripple your system with duplicate data. This is about transactional guarantees, ensuring each event is processed precisely once. You achieve this through transaction logging, checkpointing your processing state with an atomic, fault-tolerant write. Now, let's lock in performance. This is about pressure testing. Your microbatch duration and partition count form the core throttle for your pipeline's engine. Strike the right balance, too small and you choke on overhead, too large and latency source. You must find the sweet spot for your specific data volume and velocity. Now, you have a system. But under load, it can fail in ways you cannot see. Monitoring is not optional. It is your live diagnostics, revealing hidden bottlenecks before they cascade. Spark UI gives you the deep internals, but to capture your business logic, your specific events, your latencies, you must push custom metrics to a dashboard like Grafana. That's how you move from a working prototype to a trusted system. Everyone obsesses over performance tweaks, but a data schema is a living contract. Break that contract with a sloppy change, and you do not get slower processing, you get silent, systemic corruption. Your stream becomes a live factory. To evolve, you must version your data and make every new field optional. This isn't engineering, it is data diplomacy for systems that cannot afford a war. You can now ingest high-velocity data with Kafka and process it in Databricks. Spark Structured Streaming provides exactly one's guarantees for reliable analytics. Delta Lake enables both streaming writes and batch queries on fresh data. Try scaling this project by adding more data sources or implementing machine learning anomaly detection.